Ready? Okay, so let's quickly look through this. The first question says, attempt to evaluate directly by applying the L'Hopital's rule. Describe what happens. While some of you, wrote some stuff. So if I was going to apply L'Hopital's rule, I need you to at least differentiate, right? Because that's what L'Hopital's rule tells you to do. You differentiate the numerator and denominator, right? And tell us what happens to that. So, of course, you can write it in different ways. You don't have to write it word for word. You don't have to write word for word what I've written. So what I've done is, if I'm to apply L'Hopital's rule, this part, of course, I didn't allocate any point. But before you can apply L'Hopital's rule, you tell us why you're applying L'Hopital's rule, isn't it? You apply L'Hopital's rule the moment you get an indeterminate form. So I started by saying, because the limit of this gives an indeterminate form, now I'm going to apply L'Hopital's rule. Okay. Many of you just assume you can apply L'Hopital's rule directly without telling us why you're applying the L'Hopital's rule. Even though the question says that, but if you're given a question normally, you want us to see 0 over 0, infinity over infinity, or 0 times infinity as the reason you're applying the L'Hopital's rule. Understand? So, but that's a minor thing that I think we should take note. So after you apply the L'Hopital's rule, you now say, even though I apply the L'Hopital's rule because I'm getting an indeterminate form, I'm still getting the indeterminate form. And that is what you now notice. That is what the question is asking. Okay? The first reason above is the reason you're applying the L'Hopital's rule. The second reason is answering the question, describe what happens. Okay? So R1 for the reason. That is 1 mark for that reasoning. Understand? Then for B, the question says, multiply numerator and denominator by that. Actually, I want you to try this same question by multiplying by exponential x instead of exponential minus x. Okay? I thought that might be trickier, so I thought I'd give you something nice first. Okay, so when you multiply by this, some of you apply within the limit, which is multiply within the limit, which is allowed. Some of you brought out the expression and you multiplied first, which is also allowed. You notice that everybody got their point for that. So you multiply and you get this. Now the limit of this automatically gives this. I've seen a lot of wrong writing. Of course, they know what they are saying. They probably meant well, but not so nice. Somebody wrote something like infinity here, then infinity here, something like that. Please note that as x tends to infinity, exponential minus 2x does not tend to infinity. It tends to 0. Because exponential that is 1 over exponential 2x, which means this becomes so large. And so the fraction becomes 0. So when you have the negative on the exponential, it tends to 0. It doesn't tend to infinity. And that is the reason we are writing this. And you will also notice, the moment I'm dealing with numbers, 1 plus 0, 1 minus 0, the limit symbol is gone. Because that is what it implies. Okay? So that's that for the first one. For the second question, I notice some of you are applying the mathematical induction. And I think I've put why. The question says, prove that exponential, I hope you are listening, okay? Prove that exponential x is always greater than or equal to x plus 1 for all r. You see, for all x in r already disqualifies the mathematical induction process. The induction process is that if this is true for 1, assume it is true for k, then prove for k plus 1. We are always dealing with natural numbers. We are not dealing with decimals. Because for x belongs to r means you want to prove this for square roots of something, for surds, transcendental number, non-transcendental numbers. It doesn't have to be positive integers only. So for that fact alone, you cannot use mathematical induction to prove this. But if the question was exponential x greater than or equal to blah 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 for x belonging to n, then you can apply induction and see how that works. We have solved some inequality problem in the past during topic 1 when we learned mathematical induction. We didn't apply maximum and minimum principle, not because we haven't done it, but because they are dealing with natural numbers. Now that you have done maximum and minimum principle, that same question could be done in 2 ways. The question you did in the past, I mean. Could be done the way we did it in mathematical induction, and also using the maximum and minimum principle that has just been learned. Understand? So because it is not, can you go to the back next time? Thank you. But because it is, what's it called, what was I saying? Oh, yeah. Because the set involved is not the set of natural numbers, you do not apply mathematical induction. Does that make sense? So that is one misconception that I noted. I think it happened to about 2 of you. Induction cannot be applied. So, like we did in the class, just bring out the function. Isolate the function from the constant. So exponential x minus x is greater than or equal to 1. Something like this. I could have written it as 1 is less than or equal to exponential x minus x as well. Right? So this means that this is more than or equal to 1. So if there's a y is equal to 1 somewhere, everything in this function is above this point. Nothing comes here. So which means this is the minimum point. So your objective is to show that the minimum point of this curve is 1. And that's where the minimum comes in. Okay? Also, it will be easy. It won't be easier to call the function exponential x. If the function is exponential x, are you saying you want to prove that the minimum point is x plus 1? That's not possible. Because with this, it varies. The minimum point should be 1 point. Okay? But if you are trying to prove that the minimum of this is this, it means it varies with x. So if x is 1, the minimum is not the same as when x is 10. That is why we isolate it. We collect the like term sort of, such that this is separate. Then you can call this y, or you can call it f of x, your choice of notation, nobody cares. Understand? And that is what I have done in this solution. Some of you got it right, quite impressive. So I said, oh, to prove this, it suffices to show that this is greater than or equal to 1. It's enough if you can show that, isn't it? And if you can let the left-hand side to be the function, then you apply the basic stuff. You differentiate at the stationary point, that will be 0. Then you get your x to be 0 either by taking the logarithm to base e, or you just do the indices exponential x equals exponential 0. Understand? And consequently, the point is 0, 1. But 1 is what you're after. Then also you need to justify that point. Remember, your target is to show that that is the minimum point. So you need to justify that it is indeed the minimum point. So you can go for the second derivative. For the second derivative, when you put that, you get 1, which means, oh, it is minimum indeed. Because if second derivative is, if second derivative is positive, I should say greater than 0, sorry, not less than 0. Okay? I should say greater than 0. I will scan this page and upload the updated file. Okay? So, because the second derivative is positive, this is a proof that it is indeed a minimum point. So, I concluded by saying, the minimum value of that function, this is the function, is 1, which means for any value of x, f of x will be at least 1. Then you can put it back in. What is f of x? This is your f of x. It's at least 1, and that is the proof. Okay? You cannot use induction because you are not dealing with natural numbers here. Okay? Alright, so the next one is talking about this curve. I think this is a past IB question. There are 2 questions of this type, so I just pick one of them. The curve C is defined by that implicit equation, implicit function. Point B lies on this curve. Find the value of B. Now, finding the value of B is easier. You just substitute x is equal to 0 and y is equal to b. But I noticed something. Some people kept y. So rather than saying b squared. They kept on writing y squared, y squared, y squared, y is equal to plus or minus 3. Y, then I saw something in somebody's work. Since b is less than 0, but you were dealing with y. Suddenly you are saying since b is less than 0. Where does that come from? Okay? So you've been given this point, x is 0, y is b. Just substitute. Then someone forgot the fact that b must be less than 0 and decided to continue using 3, and that affects so many other work. I gave such person, I think, follow-through marks. FT. FT means follow-through. Follow-through means if not for your mistake, you are still logical in your calculation. Okay? Then I think finding the derivative of the implicit function is okay for everybody. Nobody missed that. Very nice. But then this person who left, who got 3 instead of minus 3, got the wrong gradient. Okay? And of course, got the wrong gradient for the normal. I think I kept on giving follow-through at some point, right? Then of course, so they got the wrong equation at the end of the day. So the A0 will be that accuracy is wrong, but your method is still fantastic. Then for the D part of the question, which says, we need to find the second point where they intersect. So I said using technology. There are different ways to do it. You can either sketch the graph and find where it meets, okay? Or you could just substitute, and if you substitute from here now, y is equal to, like this one now, y is equal to 6x over 11 minus 3, right? If you substitute it here, and you put the equation into your graphic display calculator, your calculator should be able to give you the coordinates of x. Somebody did it that way, okay? And the moment you get your x value, you can substitute to get the y value, something like that. Y value can be obtained from here, if you get the x value. You get what I mean? This is what I mean, in case you are wondering. So you have y equals 6x minus 11 minus, is equal to that minus 3, right? And you have y squared plus 4xy plus exponential x is equal to 10. To find where they meet, so this squared 4xy plus exponential x is equal to 10. This is what I mean. You don't have to simplify. Just put it in your calculator straight away. Somebody did a lot of simplification. It's a waste of time. Okay? I think I wrote a comment that's too much simplification, because you are not going to solve the value of x by analytic method anyway. You're going to end up putting it in the calculator. And the calculator isn't complaining. The calculator never says simplify on my behalf. So why waste your time? Okay? Or you could just, if you are explaining with the graph, I say, oh, by sketching the graph of blah, blah, blah. If you are going to use that approach, it will be nice for you to sketch the graph. Okay? So, or you could just show us this substitution and say, oh, using the graphic display calculator, the x value is this. Then you show us the substitution and you got the y value. So once the calculator gives you x is equal to 3.198, that's let's say 3.2. Then you can substitute back here, y is equal to 63.2 divided by 11 minus 3, and you can get the y value. Then you can write your conclusion that Q, which is of that coordinate, is the second point where the number intersects the curve. Understand? And the last but not the least, the question says, if u equals y to the power 4, where y is less than 0, find du dx at x is equal to 0. Now the point x is equal to 0 is not strange to us. We already know the point x is equal to 0. That is where y is equal to minus 3. So we already know that. And we also know the gradient. What is the problem?
Can you show how to graph?
You are distracting me. That could wait till I'm done. Thank you. At the point x is equal to 0, we know that y is equal to negative 3, right? And at that point, we already know the gradient already. So there are so many work that has been done. What do we mean by gradient? dy dx. We are looking for du dx. You already given the equation in terms of u and y. Chain rule is at play here, indirectly. So you have du dx is equal to, you can say du dy, then dy dx, isn't it? So this is what I'm looking for. Dy du is 4y cubed, right? Is that the u dy? I'm differentiating u with respect to y. Can you see that? And this you already know. Is that minus 11 over 6 dy dx at that point? That is question, yeah, part of question C. Part of question C, minus 11 over c. That's the gradient of the tangent. Okay, so you already have that. We know the value of y at x is equal to 0. Everything is when x is equal to 0. When x is equal to 0, this is dy dx. When x is equal to 0, you need y, you don't need x. Y is equal to negative 3, you already found that, which is the value of b from the A part of the question. So this is simply 4 minus 3 cubed minus 11 over 6, and that's it. Understand? Any questions? Remember the clue again. Y less than 0. Can you see that? Y less than 0. Why are they emphasizing on that? Let's see. Anyway, for the two values, y is less than 0. Because when x is equal to 0, you are supposed to get two possible values, right? When x is equal to 0, y could be 3 or minus 3. Is that not? Aha. So y is equal to 3, y is equal to minus 3 is this. Y, the other part will be here. Isn't it? So that is why there's the specification. There's that additional information. Oh, this is for when y is equal to y is less than 0. If this was changed to y greater than 0, you need to change a lot of things here. Do you understand that? Because in that case, this gradient is for y less than 0 also. Remember, there are two values of y, right? 3 or minus 3. This gradient was computed with the minus 3 one. Understand? So if this question was saying y greater than 0, then you wouldn't use this minus 3. Okay? And if you can't use this minus 3, then you can't use this dy by dx. Because you have to then put the positive 3 and get a different value. Then you are dealing with a tangent at the top here. Understand? Remember, there's a tangent here. There's a tangent here. The number is just perpendicular to that tangent. There's a tangent here. And there's another tangent here also. That tells you which tangent are you dealing with. But the focus is on here up to the last question, just to reduce the stress. Understand? So start. The next question, quickly. Trying to rush through this so we don't have to waste too much time. There are many ways you could see. You see, the solution that I'm showing you is not the only solution. If your presentation is logical, is well communicated, no one is going to query you for it. As long as you are giving us the right communication and everything. So all of you have done different ways of communicating and you still got your point. It doesn't mean, oh, you have to write word for word like I've written. I'm just telling you the key point that needs to be seen. All right. Suppose this happens. You see, even for this one, there are many ways. I just did it one way. Only one person actually did this way. Every other person did different way. Fantastic approaches too. Let u be this, then the entire question is this. Then you can use the ready-made answer that we know that this will happen, right? And if this is u, then you can find your du dx, okay, which is just 1 over a. Then you can apply the chain rule. And of course, when you simplify this, you get this out, it comes to the top, and there's a cancellation. Other people did different ways, and that's also allowed, okay? So you can have different ways of doing it. So somebody did, if arc sine is this, so sine y is equal to x over a, then cross multiply, that's also allowed. This is what I mean. Someone did this, or maybe few people actually, arc sine x over a. So by this, it means sine y is equal to x over a, which means x is equal to a sine y. Can you see that? Then immediately dx dy. Okay? Dx dy should be a cos y. Somebody omitted this a. And eventually got the right answer. So I'm like, okay, it doesn't work. Sorry. The fact that I said show that doesn't mean you can just write that as the final answer and expect me to fall for it. No. Okay? So this is that. Then there are many ways to get the expression for this, because at the end of the day, this will be dy dx is equal to 1 over a cos y. Is that not? So to get the value for cos y, you can use the triangle Pythagorean identity, or you can use the right angle triangle, your choice. So someone did cos y is equal to the square root of 1 minus sine squared y, and because we already have sine y to be this, they substituted. So that is 1 over a square root of 1 minus x squared over a squared, and clearly this is 1 over, all right, a roots, not 8 roots, okay, a root x squared, no, a squared minus x squared over a squared. Can you see that? Then this can leave the square root and cancel that, and you get your result. Other people did this. From here, the angle is y, then this is x, and this is a. So that this is a squared minus x squared. And from here, cos y is adjacent over hypotenuse. So when you get to this point, if this is a denominator, it's going to be flipped. So basically, this is 1 over a square root of, no, actually there's no need for flip, because this can cancel, and you get your answer again. So there are different approaches. This is just one of them. Using this approach, you have 2 different ways also to conclude. As long as you get something logical, you are good. Understand? So quickly, number 5, evaluate this limit. This is something we did in the class. Now there's a misconception again when applying the L'Hopital's rule. I still don't know how people apply L'Hopital's rule and end up getting products. 2 people did that. L'Hopital's rule says if f and g are differentiable, limits of this rational function as x tends to a is the same as limits as x tends to a of that and that, something like that, okay, provided it exists. So this actually is the limit of that, and if that limit exists, we're saying this is f of a and g prime of a. So this is equal to this. That's what L'Hopital's rule is talking about. L'Hopital's rule never said this is this times this. So I don't know where some people got this from. I saw that a lot in 2 different questions. So for the first question, it's easy because it's going to give you 0, 0, then that is an indeterminate form. And as a result, you differentiate them separately. 1 over x over 1. Derivative of x is 1, derivative of this is 0. That's how you got the 1. Okay? So that's why I wrote this. Since this is of the indeterminate form this, we apply the L'Hopital's rule. So this limit is the same thing as this limit. The limit of the original is the same as the limit when I differentiate. That's what I've done. Okay? So that's like d dx of this, d dx of this. We always differentiate quotient like that, but without applying the quotient rule, of course. So, and if you get this, which is simplified to this, you don't need to differentiate anymore. You just substitute. So, I don't want to see products. There's not even explanation, justification for that product. I don't know where that comes from. And that affected some people a little bit. Then this, the second one, you have to apply the L'Hopital's rule twice. Because if you apply it at first, by L'Hopital's rule, because it's going to be in the indeterminate form, by L'Hopital's rule, that's 0, 0, form 0, 0 also. I skipped that part. I just said by L'Hopital's rule, this is the same as this. What is this? The derivative of this is this one. I differentiated immediately. Then notice what I did. I simplified, right? And I said it still gives the indeterminate form, 0 over 0 again. Then I say apply the L'Hopital's rule again. So let's take this as the beginning again. The limit of this is the same as the limit when I differentiate the function again. So the function was differentiated. There's no 0 again. We don't care if there's 0 at the top, but 0 cannot be at the bottom. That's the point. We can have infinity at the top, but we cannot have infinity here. Okay? We cannot have infinity over infinity. But if you have a number here and infinity here, then yes, maybe yes, because that tends to 0, right? So that's a possibility. And that's how you conclude. So be careful. We can apply product rule in L'Hopital's rule when we have, when you're differentiating the top and there's a product of function. Yes, we'll do that. Because remember, L'Hopital's rule says derivative, right? So the rule of differentiation applies. But your derivative is derivative at numerator, derivative at denominator, separately. We are not saying derivative of the rational function using the quotient rule. So how you differentiate your numerator is based on what you see and what you know, right? And the function provided. Understood? All right. Now, 6. Easy stuff. Is that the last one? Yes. Okay. Given this function, find dy dx. Easy stuff. A lot of people, in fact, everybody got that. Prove by induction. Induction. When you're proving by induction, you don't even need to do one again because you've done it. I think everybody did wonderful there. By quoting the previous result. I don't like chit chats when we're having a serious discussion, please. By quoting the previous result, everybody did something nice there. I love that. Then you assume for k. You assume for k. You assume this is true for k. Okay, I just go through with the solution. This is the first part. The first derivative. You use product rule, of course. Easy. Then I said, Pn is the statement. The statement is not this alone. I saw someone wrote, let Pn equals to d2, dny, dxn. No. That's not Pn. Pn is the statement that for the n derivative is equal to this. Just like saying P1 is the statement that the first derivative is this. It's a statement. The statement is not just the left. A statement like, oh, the boy in question is Ethan. That's the statement. The statement is not, oh, the boy in question. Understand that? So when we're talking about the statement, you're talking about everything that needs to be proved. And you should avoid using equals to. Let Pn be, because there's an equal to expected here. Mind the way you write. Okay? Let Pn be the statement this. Understand? Then for n is equal to 1, we have found in A already that this is the case. Right? Then if you look at it, left hand side, this is what by differentiating. Okay? This means you have to differentiate. This means you just substitute. So your left-hand side is this one. Where is it? Okay. For n is equal to 1, I have this. Right-hand side is when I substitute. This left-hand side is from the previous question because left-hand side is differentiate n times, right? So when n is equal to 1, left-hand side means differentiate once. Right-hand side means substitute n is equal to 1. Can you see the difference? Differentiate once is the result you have already obtained. That's what I just quoted here. For the right-hand side, you just substitute, and you see that they are the same. Then you say, oh, so n is equal to 1, then P1 is true. Okay? Then we suppose it is true for n is equal to k. So you just say, suppose that Pk is true. Or you say, suppose that Pn is true for n is equal to k. It's the same thing. And you just state what that means. That is, this is what I mean. So you state your inductive hypothesis is expected. Now we prove for pk plus 1. Somebody wrote, now we prove for pk plus 1 and decided to write this is equal to the answer. And they said, therefore it is true. What have you done? You haven't done anything. You just copied and paste. Nothing has been done.